Hi, I'm Tate Connor. Thanks for tuning in to our amazing videos that are of the highest quality to discuss trail maintenance on existing trails. Now, a few disclaimers. This is a long format video. So I encourage you to stop driving if you're going to watch this video and maybe consider getting a drink and getting comfortable. You could put AirPlay on your smart TV and watch it with the whole family. However you choose to consume this, buckle up. It's gonna hopefully be a fun and entertaining video that provides a little bit of education. This is to help train folks that are gonna do some maintenance for us so that we can have a better quality of product and elevate everybody's capability. So today we're gonna talk about drainage. We're on a trail that is on an old road, which is one of our challenging places to do drainage because of the nature of how roads traditionally handle drainage and how trails handle drainage. In this video, we're going to talk specifically about water bars. We're on a Class 5 trail. The Class 5 trail corridor is 6 feet wide by 10 to 12 feet high. That's the open corridor of vegetation and where the trail and the appurtenances of the trail originate. Within that corridor, there's a trail tread. That's the designated area that we want people to hike on. For this trail, it's an 18 to 26 inch wide tread, regardless of the old road bed. So when we talk about the trail tread, we're going to talk about where we want people to walk. The trail corridor allows for that winter use. It allows so that there's not vegetation hitting people as they hike. And then the drainage devices that we're using, they extend off the trail tread. They extend beyond the trail corridor so they can properly take water out of the system. And that's important to consider so that we don't have water backing up into the system, making this all a moist, wet, and non-durable tread. So I mentioned that this is going to be a fun video. Our post-editing will be a little bit weak, so we're going to queue up the specifications that we're going to be following for drainage. So, this would be a great time in post-edit where we would put up a fancy thing, but we'll just pause the video and allow people to absorb all that information. And we'll talk about that in just a minute. So, for our drainage and our water bar, we want to slowly have the water go off the trail. We do not want the water to come to the water bar and change direction, because when the water comes to the water bar and has to change direction, it slows down. And when it slows us down, it drops its load. And that means that the water bar will fill up. And then once it fills up, material is going to be in the way. The water will be able to go over the berm and go down the trail. So the overall thing with the water bar, we want to think about a nice arc to take the water from the trail down, across, and out the outlet. Now you'll notice that there is a pipe, a steel water pipe, at the outlet of this trail. We're on land that used to have a water supply. We'll eventually cut that out, but unfortunately our root loppers weren't very good at cutting an old steel pipe. So there's a couple of different components to the water bar. There's the funnel that is the first part of the water bar that comes into the trail tread. This is what collects the water and brings the water into the drainage ditch or the outlet. And then there's the berm. This is the big part of the dirt that goes up above the trail tread and does a big arcing dome down the trail. Think of it like Captain America's shield being put on a table. We want that big long berm so that it has support as people are hiking on it. So when we're digging our drainage, we want to make sure that the drainage is below the lowest point in the existing trail where there is erosion and low points of tread. We want to be 6 to 8 inches below that so that the water is cutting and turning against undisturbed soil. Okay, that's critical. We don't want water to be up on the berm. Say there was a massive tsunami of water coming down behind me. That's what the berm's for. we want the water to turn and never hit the berm. Our funnel, we want to have it be 3 to 5 feet in width, and we want that funnel to taper up into the trail tread. For our trail tread, we want 3 to 5% outslope so that the water will sheet off of it. And in the funnel and in the drainage ditch, we want greater than 5% slope so that the water will continue moving down. Whatever this depth is, when you clean it out, you need to carry that 5% to daylight on the outlet. When we're in the outlet and the drainage, we want to make sure that we don't continuously dig and clear the material backwards, because you can see how long this drainage already is. This is probably about 15 feet, and there's another 4 feet behind me. All the material that was previously up on the trail would have come down and been deposited. If we keep dragging the material like this, it's going to go further and further. It's going to be like a push-up. So we want to bring the material perpendicular to the drainage ditch so that we're not continuously going further in the future. So please bring that material back. We want a 12-inch or greater bottom to our drainage. Now, for reference points, a shovel is not quite 12 inches. So that's a lot wider than most of the hose that people will be using to clear. So it is a nice wide bottom, and then we want to taper it up, ideally at a 45-degree angle or 100% slope, so that there's no overhangs. Any of the roots that are in there, cut them out. And we're talking about removing organic material that's come from the leaves and stuff. We're also talking about all the sediment that has come down from the trail above. Right here, this trail used to have material, and that material eroded because we didn't have good drainage maintenance. So now with this water bar, any of the water coming down to this system will be ejected and go out there. And up above, we have more water features that'll slow down and reduce the volume. Holistically, across this whole slope, we're going to have a set number of devices starting from the top in order to mitigate the water's velocity and the erosiveness of it by the time it gets here. So this is some of the overall prep stuff for doing the maintenance. When you're digging all of this material, and with all of our maintenance, where you're digging material that's been displaced, if you find rocks that have been displaced or in the process of clearing a drainage, feel free to source those and put them on the uphill side of the trail. So in the future, as we need to build something through a detailed work plan, we have material available to us, and that's going to make life a lot easier. If it's smaller rocks, the size of marbles and up to like tennis ball size, those can get, and it's in mineral soil, that can be put behind the water bar in the berm. You can take any good mineral soil you find and resurface areas that have been displaced. So we'll talk real quickly about the berm. Always with our water bars, we want to focus the user on the uphill side of the drainage. So as the water comes down the trail, it will start to sheet to the downhill side with that 3 to 5% outslope, and the user doesn't have to go down the full 6 inches because that area will eject the water and then they'll be into the funnel. Ideally we want the user to not have to go up and down too much or step over a berm, and any of that material we can fill in the back, and again, shooting for that 18 to 24 inches of mineral soil, and just any of that material that's good, throw it right on there, and the rest of it we can surface and build later when we're doing detailed work. Thank you very much, and thank you for volunteering to do drainage and doing a great job.